Hi, y'all. This is Bree. Sunny is out tonight, so I am taking over the show and bringing some science with me. I got guest. We got David. We got Dr. Kastner. We've got Dr. Ben Davis, and we are going to have a good time talking about space, time, measurement, and causality. So sit back, relax, and enjoy your time in the sunny spot. All right. Hey guys, thank you so much for joining, returning really to this topic. We just got to brush the surface of it last time, it seems, and there's a lot more to be said. So I'm glad everybody was able to come back and join in on this. So you want to kind of do like a little round robin, and everybody can introduce themselves. Go with David and then Cease and then down to Ruth and Ben. David?
Yes, thanks for having us back again. I'm a college professor. I study black holes.
Awesome.
Okay. Yeah, thanks for having me back. I appreciate it. I go by Ceasetoknow. I do a YouTube channel on my own podcast called Axioms on Trial, where we talk about philosophy, religion, politics. Yeah, I'm glad to be back. So thank you for having me on.
Awesome. Dr. Ruth.
Oh, hi. I'm Ruth Kastner. I'm a philosopher of physics, and I have an affiliation with the University of Maryland, and I'm currently on the West Coast in Portland, Oregon. And nice to join you again. Thanks.
All right, awesome. And Ben.
Okay, I'm the odd duck, I guess. I am a professor of physics now, but most of my career I was a software developer. I do have a degree in nuclear physics. But I couldn't find a job in that area, so I had to go into a whole other line of work for a while. I was a software developer for 20 years, and then I was controls engineer for about 5 to 7 years, and then I finally got my teaching gig a few years back. I teach engineering and physics here in South Carolina.
Awesome. Excellent. I'm so happy to have everybody here. You're all so knowledgeable in your fields, and it's amazing to be able to get all these minds together to talk about something so I don't want to call it abstract, but I'm, as a lay person, I don't know like what is space, what is time, all these questions that I have. But yeah, let's dive right into it. You guys, what do we say about time and causality?
Where do we want to start? Time, measurement, causality. Maybe measurement might be a good place to start.
Okay.
Maybe I'll start us off. So measurement in physics has been, up until the 20th century in quantum physics, a fairly straightforward thing. The idea that the physical world is in a certain state, and that you can look at it and find out the state in which it's in, has been relatively straightforward. And we sort of expect our physical theories to tell us what's happening, what the state of the system is, how it's changing with time, and measurements just sort of verify what the theory tells us in a very straightforward way. And that project seems to sort of fall apart, and it's sort of unclear the extent to which it has fallen apart. And so I guess we'll get into this. But in a sort of straightforward way, when I was a student and the way quantum physics was taught to me, the professor described this, even at the mathematical level, certain states, certain physical states, descriptions of physical systems. And then, strangely, you look at these physical systems, and it's somewhat subtle. And it's strange because it shouldn't be subtle. Most students don't even realize that the result of a measurement seems to be incompatible with the state of the system. And so there's something's happening in the measurement that you end up getting something that doesn't seem to be directly related to the description that you get from the theory. And so you say, well, I have this description that has all of these different things in it, and then suddenly you make a measurement and you end up at a certain place that seems to be different, connected in some way to the state of the system before the measurement, but you never understand how it is that you end up there. I've never received a satisfactory explanation as to how you went from doing an experiment and you ended up in the state in which you ended up. So you measure the state, you end up in a very precise place, but it's connection to where you were before in the state.
We're losing some audio from you, David.
I don't think it's from me.
Something just got a little, your relation to your mic might have gotten a little.
Can you hear me?
Yeah, we can.
It's good now. It just
clear
it
now.
just dropped out for a minute.
Dr.
right when
Kastner, I think it's coming from you. I think the noise is coming from you. Like the street, I think it's not coming from me.
Oh yeah, the train.
Well, it's
Something has
good
a
now.
train in the background. Yeah, but
Okay. Well, anyway, let me sort of wrap
it's
it
good
up.
now.
So I've never received a satisfactory explanation as to how you ended up with the result that you ended up with, and you start to end up with explanations that involve multiple experiments and probabilities and distributions, but I want an explanation to what happened in my one experiment, and I'm still waiting 20 something years on as to what that explanation is.
If I could just kind of elaborate a little on David's really good introduction to this problem. I mean, basically in quantum theory, it's called the problem of measurement, or the measurement problem. And I want to kind of highlight that it really has two features. The first is in the sort of standard approach to the theory. The theory itself cannot even tell you what sort of interaction counts as a measurement. Okay, so that's one aspect of the problem, and that kind of goes along with, it's sort of a technical idea, but the idea of a basis. You've heard the term maybe observables, in quantum theory. These are things that we can measure. But as David noted, it doesn't mean that the system already has some sort of property corresponding to that observable. So take, for example, something like momentum. Okay, that's an observable. You can measure momentum if you want. But that, in order to do that, you have to kind of say, well, what is the interaction? Besides just getting kind of correlations and things, what is it that actually precipitated some sort of a situation where I'm going to get an outcome of a particular momentum? But then the second part of what's considered part of the problem is that even if you're able to define a specific basis and say, yes, I'm really measuring with respect to, say, momentum, that the formalism doesn't tell you which value of momentum you're going to get. And I think these are important to distinguish, because the latter case, the second feature is really a form of indeterminism. It's the theory saying, I'm sorry, guys, this is an indeterministic theory, and there's no deterministic story or mechanism that is going to get you from, your state of uncertain momentum to a particular certain momentum state. So if someone wants an explanation or an account that will give you that, the standard theory is not going to give you that. And I've argued, what I've done in my work with the transactional interpretation is I've presented a specific physical account of the first that resolves the first aspect of the measurement problem, which is it clearly defines a physical interaction that gives you the measurement process that you can say, okay, a measurement happened. But it's not going to tell you which one of the possible momenta you've got, because again, this is fundamentally indeterministic. So this sort of, this is getting into some technical stuff, but it's sort of a two-headed issue. And I've, I would claim to David that, if you read, and I can give you some references, if you read, my latest second edition of my Cambridge book on the transactional interpretation, in chapter 5, there's a very specific account of what is a measurement, why you can't say what is a measurement in the standard theory, but you can in the transaction formulation. And it involves some physics that's kind of overlooked in the standard theory. So we get that, we can define what a measurement is, but again, we're going to get a set of competing probabilities. And this, I would say this shouldn't be sort of viewed as an insufficient physics account, because, for example, it involves, you could say, symmetry breaking. And we do have symmetry breaking in other, accepted physical theories, such as the Higgs mechanism and so on. So physics already has this concept of symmetry breaking, where the theory will give you a set of kind of solutions, but it won't tell you which solution nature is going to end up with. And I would suggest that the second aspect of measurement is that kind of situation. So that I would say that's not so much a problem as nature, if you will, if quantum theory correctly describes nature in this probabilistic way, that there is a fundamental indeterminism. So anyway, just to kind of summarize, there's two different features, and I think that the transactional formulation clearly resolves the problem of not being able to say what a measurement is. But because the theory is indeterministic, it's not going to hand you a deterministic account from a state of indefinite momentum to a particular. Right.
With grace. All right. Anybody
Sorry.
else want to?
Not in the studio.
Yeah. So
I
it's
wanted to
okay.
just-
It happens.
I wanted to jump back with something. So I think I have a good sense of how TI or RTI resolves the physical aspect of how a measurement occurs. But you said that we should not worry about understanding how we ended up in the precise state that we ended up with. And that, I want to push back a little bit on that, because that kind of bothers me. And you appeal to the concept of symmetry breaking. So symmetries are broken in nature, but that sort of gives you some sense of the possible outcomes, but it doesn't tell you how you ended up where you ended up. And that really bothers me. I don't understand the difference. So when you say there's an indeterministic theory, I don't understand the difference between an indeterministic theory, which ultimately doesn't tell me why I got what I got in my experiment, and a theory that is incomplete, where you kind of suggested that we shouldn't think of this as an incomplete kind of description. But it seems to me that these are kind of like the same thing. And this is not incompleteness a la Einstein, if I understand. Einstein was complaining about, was saying that superposition was an incomplete description. If I'm fine with superpositions, but I want to know what happens in that measurement, in that one experiment. I don't want to do 2 experiments. I don't want to do 3 or more experiments. I don't care about probability distributions. I want to know what happened in my one experiment. I'm a cheap experimenter. I want to do one experiment. And if you don't give me an answer to that, it seems to me that your theory is incomplete.
So here we get to a fundamental ground rule of traditional physics, if you will, that David has, just given us here, that as a fundamental ground rule, that there's a demand that for a physical theory to be complete, it must be deterministic. It must be causal and deterministic. And I'm questioning that. And here's what I'm here's what I would say. Suppose, when we play along for a second, just to kind of for argumentation purposes or whatever. Suppose how about the idea of volition? For instance, if volition is a real thing, there's no room. This could get us into like a side topic for, another 10 episodes. But if you insist that to be scientific, a theory must be deterministic, then you're basically saying that no scientific account of a world can be possible unless that world is deterministic. So now if you insist that your world be deterministic, then that means that you've got essentially classical physics kind of paradigm where every input leads to a unique output. Everything that's going to happen is, like Laplace said, essentially fated. And there's no robust free will in a world like that. Now, I know you can give a compatibilist account, and that involves redefining the term free will so that it means I'm free if no one's holding a gun to my head. But meanwhile, I'm free to simply, as a mechanical system, act out every input that was put in place prior to my being born, and so on. Now, if people want to call free will that, I would say that's kind of draining the concept of all its meaning. So I would say that if that's one way to look at this situation, is to say, if nature is really has this room to move in it, where you have genuine options, folks. You have genuine options about what to choose. Then the correct scientific theory, I would argue, is an indeterministic theory, because if you want to assert that I can freely choose what to have for dinner, then nature better not have already mechanistically, deterministically chosen it for you. So I would say that we need to question this sort of ground rule, that to be a good physical theory, to be a complete physical theory, you must be causal and deterministic. I would suggest that that we question that.
I want to jump in on this issue of free will, because at least from my experience and my readings, I've never heard of a concept of free will that has really made much sense to me. And I don't think that, I guess in my concern, kind of going back with the last conversation that we had, was what was just said about the measurements and the problems there, is I am concerned with if we are recognizing that the science is undermining our intuitions, which is something that we should expect when we look at the reality on the deepest level imaginable. Well, then the question becomes, what picture are we creating from the science that we can understand and conceive of and express and translate in a way that makes sense? If that involves reshaping our intuitions, that's fine, but there still has to be a kind of translation that takes place, and that's where I think philosophy and science can work together. I don't think that a notion of free will makes much sense to me. To me, it's like saying things just happen without explanation. That there is this context.
No, you make them happen.
Yeah, but what does that mean, right?
You choose it.
Yeah, but that to me seems to sort of it sounds almost like a miracle claim of sorts, where something just happened without an explanation. What does it mean to make something happen?
Well, it depends what kind of explanation you want, right?
Right.
I mean, actually, I do have a specific paper. I mean, that's fairly technical, that I totally get Cease's concern about, what do we mean by free will? And, like I said, I mean, this is a notoriously, kind of a minefield of obscure concepts and ill-defined terms, and I totally get your concern there. I do have a specific paper. I'll try to put it into the chat, where I do try to get very in more specific terms, I think that would be helpful for CSIS concerns here. That I don't want to belabor, given the short time we have here, but I can put that out there. And it's a paper called "The Born Rule with a Probability Rule and Free Will." And what do I mean by that? How is it that the quantum theory, the probability rule, or the indefinite, the indeterminism inherent in quantum theory, how does that relate to free will? So I can definitely offer that to people who want to, cut through whatever you think BS I'm coming out with here, and get through some hand waving and actually see, okay, I am being very specific here. But and it's not free, it's simply that, if you will, I would grant that I don't think the word miracle is really right, because it has this pejorative anti-science connotation and of the woo, thing. and so I just won a dance contest, by the way, at a wedding by doing that. Anyway, so yeah,
I'm here for it,
as
girl.
far as
Yeah.
miracles, okay, good. So I'm just getting, the older I get, the sillier I get. It's like I just never grew up, actually. But
we like to be a fun channel here, though. So yeah.
Okay, well, good. I love fun. So yeah, I mean, as far as miracle, I guess what I would say is that the notion of just sort of I don't pretend to know, well, what is a mechanism for, my deciding to raise my hand, I don't purport to have a causal account of that or anything like that. But again, I do think we need to be wary, or at least aware, of the idea of saying a good theory must be a deterministic theory, because that's imposing our desires onto nature. Nature, if you read chapter 2 of my book, my CUP book, I discuss how Heisenberg came up with quantum theory, not because he wanted it, but because his classical deterministic causal mechanistic models were not working. And instead of trying to make those work, he just looked at the data. That's what we do. We look at the data. We say, what sort of theoretical structure allows me to correctly predict in some way, even if only probabilistically, what I'm getting, and in particular, the atomic spectral lines. And the quantum theory, with its crazy, Hilbert space structure that involves sort of this intrinsic indefiniteness, it just came out of it. Nobody wanted it. And I think we have to respect that. And I think we have to be good learners and say, look, this is the theory that nature forced on us. And it doesn't come with a deterministic account. Now, you can force a deterministic account on it if you put in hidden variables. But whenever you do that, you're always helping yourself to stuff. So I would just say, yeah, go ahead.
The thing I would say to and I don't want to get too stuck on the free will issue, but I do want to say one more thing about it, is that we often hear from both scientists and philosophers that we have this illusion of free will. And I want to say, from my perspective, we have an illusion of an illusion, that actually, when we look at our deeper experience on a closer level, that we're actually this idea that we're freely choosing anything fades away. That and I think Harris is somebody that talks about this in some of his work, where he comes up with a thought experiment of, if I ask you to think of the name of a city, and a name appears in your consciousness, in what sense do you choose anything there, as opposed to just having the experience of a name emerging from your conscious experience?
I have to push back on Sam Harris, because his argumentation is incoherent, and I have a blog post about that. So yeah, and I mean, by his own standards, he was not the author of his book. So he's kind of self-refuting.
I don't think
anyway, you can deny that you have free will. You can absolutely do that. You can absolutely say the world is completely deterministic and I don't have free will, and my sense that I have free will is an illusion. One can definitely say that. Quantum theory won't back you up on it unless you
Right.
sprinkle in hidden variables or something. But you can a lot of people say that, and you can definitely say that. But I mean, then you shouldn't also say, for consistency, then you shouldn't also say, like Sam Harris does, well, people often feel, dispirited by finding out, as he claims, that they don't have free will. So I would advise people to just, behave in a good way. Wait a minute, Sam, you can't tell people how to choose how to behave. You just said they're marionettes on strings. And so he's constantly refuting himself. And he's also completely out of touch with the neurological, the neuroscientific findings that showed that, for instance, that the Benjamin Libet experiments, that the results of those were completely, interpreted in a really unsupportable way. And he has not kept up with those findings. And I've written stuff about that, that he's ignored, but he's welcome to look at it any time.
Well,
but like I said, you can definitely say you don't have free will. You can definitely say
and I would be very open to reading what you just described. I would say, though, as a quick response, is I don't think that saying that free will doesn't exist means that we can't ourselves think of arguing for how people should behave as itself being a cause in the chain of causes. I don't think saying that he's an author...
You don't have any live options. You're a marionette on a string. You have no live options. You don't choose anything. So, I mean, they're trying to, this is the problem. This account of, I should feel good because I don't have free will. It's all an illusion. But people still want to claim that they can decide how to behave or consider my options about how to behave. No, you have no options.
But no, but it's a reframing of what is meant by options and choice. Nobody's saying that we don't have will. So
you redefine.
Well, yeah, it's the idea here is not.
So the marionette on the string has will. I mean, this is Sam Harris's title of his book.
Right.
So the marionette's doing what the strings tell it to. How is the marionette supposed to choose how to behave? I mean, it's just self-refuting.
Well, no, the idea is not that when it makes a decision, it's freely choosing how to behave. The idea is that when we look at and we are part or engaged in the world, that shapes how it is that we end up acting.
No, but no, it doesn't, because then we are acting as a domino being hit by another domino, and we're falling, and that is the account. And right. So when you tell that domino, now listen, Mr. Domino, I even though the idea that you're gonna, whether you're gonna fall or not and how fast is determined by all the dominoes before you. How about if don't feel bad about it and consider how that you're part of the massive network of dominoes, and you can feel good about okay, so I can feel good about falling while I'm falling. I mean, it's empty. I think it's empty. I think it's double talk, and I think it's trying to have it both ways.
But from my perspective, the feeling good or bad about it is not relevant to, what I care about.
No, but I mean, it's choosing. Harris comes back where he says, I would suggest that people choose to act, and he uses language. He uses volitional, intentional language to try to rebut this finding that it's a scientific finding that, and I have this in my book and in my blog post, that people who have been convinced that they don't have free will, there are scientific studies, data showing that their social behavior deteriorates. They cheat. They are inconsiderate of others, and it's concrete scientific findings that people's behaviors are negatively influenced by that. So it's, and I think Harris is trying to, in his book, he's trying to kind of push back on it and say, no, be a good person. Be a good person. And so again, he's got the marionette that he says is on strings, and he's telling the marionette, be a good marionette. And as a marionette, I'm going, ha ha. You just told me I'm a marionette. And there's
definitely a lot that can be said there.
Maybe we should point out that the idea, even if quantum physics is fundamentally indeterministic, that doesn't mean that we have free will.
And
No,
it
it
also
doesn't. And a
mean-
lot of people, and I push back on that too. I have a specific argument about, because so Cider, a philosopher named Cider has addressed that and specifically claimed that quantum theory, pointing to quantum theory probabilities doesn't mean we have free will, and it doesn't prove we have free will. But he claims that we have to be a slave to the quantum mechanical probabilities. And again, my paper that I can link for you on the born will and free will shows why that's not necessarily true. So, I mean, again, here, like, I would never say quantum theory shows we have free will. I would not claim that at all. I would simply say that if we do, in fact, have robust free will, if we do, in fact, have live choices, if there are any live choices in nature, then these actually have a very nice theoretical referent in quantum theory, so that quantum theory at the very least leaves room for that kind of picture. So that's all I'd say. I would never say, oh, I know I have free will, because I don't know if I have free will or not. I would simply say that the deterministic account does rule it out.
I do want to hear from Ben as well, because he hasn't talked
Sure.
to, but I wanted to say a couple of things.
Talking a lot.
Look, I don't think that if our measurements or nature is indeterminate, I don't see. And again, I'll definitely look at the work you're mentioning, but I don't see how that can lead to some notion of free will. I don't think there's anything about. Sure, I don't think there's anything about what Harris is saying, whether or not I agree with him, that is self-defeating. I think he takes a particular stance that I think.
Well, I argue that it is self-refuting, but I can show you that. Yeah.
But I also want to add that going back to what was said about measurements in nature, that yes, of course, we shouldn't be trying to project our desires onto the science. But I don't think that, going back to what David was pointing in the beginning, if what we're seeing from the theories and the science is that something isn't matching up with the way nature is actually functioning, there's some ambiguity there. But maybe the reason for the ambiguity is that there's something that's not being done, that's actually corresponding to what is actually taking place. That there's something in principle in the approach that is failing to correspond in some fundamental way to reality. And maybe that and now maybe that could be, I'm not saying that's the case, I'm saying that is the concern, certainly for someone coming from where I'm coming from, which is that I'm trying to even understand and translate the science into something that's comprehensible for people that are outside of the field. And so it's not so much, I think, a projection of what we want to be the case. I think it's recognizing that there's a wall we're hitting there. But yeah, I don't know. I want to give other people a chance.
Well, I mean, if there is some volition at the heart of nature, then that's how it could show up. But again, I totally agree with you that certainly the standard theory utterly fails to even tell you, well, what is a measurement? And I have the same problem with the standard formulation of the theory, because it's unable to even tell you how do you do a measurement? What does that even mean?
Real quick, we had a question here, and I wanted to get to it before we move too deep into the topic again. So is the effect of a cause indetermined then to say there is limited possibilities still, but still a possibility of some different results?
They're very tightly constrained. Yes, they are very tightly constrained, but you only get that from the transactional formulation. You only get an account of well, why did I get this particular set of possibilities? The standard theory can't even tell you anything at all.
So Ben, where do you stand on quantum theory and determinacy? Are you on the determinant?
What do you mean by determinism, though? I mean, because probabilities to me doesn't mean that it's not deterministic in some way, right? I mean, part of what I see here is I sort of view this as the resolution of reality, right? You can drill down and you can drill down and you can find smaller and smaller particles, but at some point, no matter how good your instrumentation is, that particle is going to become this fuzzy thing that doesn't occupy a finite area of space anymore. And so that then has to be modeled as a probabilistic thing. If you try to grab that particle and hang on to it in some way, or measure that particle in some way, you're forcing it into some spot in space and you're taking its momentum away. To go talk about Heisenberg or whatever. So you're locking down its wave function. But if you let it go, it's going to become fuzzy again and it's going to start floating around in space again, right? And this becomes a fundamental limit on what we know about reality. That doesn't mean it's not deterministic to some degree. If you shoot a particle in that direction, there's a 50% chance it's going to end up against that wall versus against the wall behind me. There's some finite chance that it might go backwards, but it's not very likely, right? So it's still telling you something. It's not telling you nothing, but it's kind of like you can't ever know anything to 100% certainty, just like you can't measure something to 28 digits, right? There's some limit on the measurement no matter what you're doing. That's an experimental point.
I would say that's, you know, if in giving this account, you would say that that's an intrinsic limitation, you know, to nature, then that would be what I'd call ontological uncertainty. That corresponds to a form of indeterminism. So yes, we do have the Schrodinger evolution. We do have a deterministic evolution that applies to a quantum state. But again, that quantum state can have this ill-defined character with respect to something like position or momentum or the usual observables that we're used to in classical physics. And that even though you've got a deterministic evolution of your quantum state, that's still not going to give you a one-to-one, you know, input to specific output from that state to a particular position. So that would be, you know, fundamental indeterminism.
I want to address Ben's
millisecond how fast I'm going to get home when I drive home tonight either, right? When it's stoplight here or stoplight there, I know it's roughly going to be 15 minutes, but it might be 12 minutes, or it might be 18 minutes, right?
Ben, so I wanted to address your comment on uncertainty, and I think that uncertainty in that sense emerges directly from the idea, from the fact that we are forced in quantum physics to describe particles as waves, right? So waves I can get the uncertainty principle directly from waves, and then we get uncertainty in particle properties from wave properties. So in that sense, there's an ontological uncertainty. But but what about the measurement issue? So what happens in that transition? And this is the thing that, you know, Dr. Kastner, you said that I should something to the effect of I should have an open mind. I think of myself as being open-minded and exploring the possibility of a theory that is indeterministic. The problem is that I never understand what that means. I can't distinguish. I find myself incapable of distinguishing between what's called an indeterministic theory and the alleged explanation in that indeterministic theory, and a theory that simply has nothing to say about that. Again, I have a superposition. I can create a strange superposition in the laboratory. I can manipulate a physical system, produce a superposition state, and then make a measurement and get an outcome. I want to know what happened. Yeah. You're telling me that you have an
quantum theory. No, quantum theory does not. It's true. Quantum theory has nothing to say about which outcome will be actualized. Now, in the transaction formulation, it does have something to say about what it was you did that gave you those specific possibilities. But absolutely right. Quantum theory has nothing to say about it. And here is where I would suggest, once again, that, you know, whenever we talk about, you know, I got to say, I know that this group has, you know, one of the perhaps, you know, missions or founding ideas of this particular program is to question and be skeptical of the, you know, what Harris calls woo. Well, I'm skeptical of Harris's own woo, you know, but I do think that it's important to recognize that science as an empirical form of study where you are looking at empirical data. You are restricted to making theories that ground you appropriately in that empirical data. And that's how we came up with quantum theory. Now, the theory is mute, as David points out. It's mute on, well, how did I get from weird superposition to particular result? The theory is definitely mute on that. Now, does that mean it's a bad theory or that there's something wrong? Or does it mean that science needs to have a bit of humility and recognize that there may be some questions that go beyond scientific theory? And again, I go back to, again, if there's real volition at the heart of nature, Sam Harris would call that woo, because you can't give a causal account for it. But suppose nature's standing there going, ha ha, guys, I got volition, and that's not a thing that you can put in an empirical theory, in a mathematically formulated theory, but I'm going to frickin' do what I feel like doing, ha ha. And you may not be able to explain it. And each one of you is a crazy person, may not be able to give a causal account of why you chose to have what you did for dinner, but that doesn't mean that you didn't in fact do so. So, I'm at the,
but how would we know?
The theory can't tell us.
But it sounds to me like you're expressing something that seems, or sounds at least on the surface, to be unfalsifiable. If there was this volition to nature, this
falsifiability is bogus. You can't use falsifiability as a criterion for either scientific theory or sound reasoning. And that's been established for centuries. That Popper's, his heart was in the right place. That the idea is, look, if you want to have a good theory, go out on a limb, make a prediction, and stick to your guns. But that's not the way science actually works in the real world, and that's been well established. That
I'm not
just
saying
because you don't have a falsifiable assertion doesn't mean that your reasoning isn't sound or that you don't have a good argument.
Yeah, but I'm not saying that falsifiability is the only thing that matters. Obviously not. There are many factors that go into constructing a theory worth something. But I don't think that we can throw out falsifiability out the window. Because at that point,
I'm not.
I'm not saying that you are, but I'm
window.
saying that when you say that it's bogus, it concerns me, because I would say that
used as an objection to what I just said. I mean, I think that invoking falsifiability and saying that what I had just said about if nature were volitional, which I'm not asserting, I'm saying, who knows? If nature were fundamentally had intentionality, science can't. Science is mute on that. Science has nothing whatsoever to say about intentionality.
But if that's the case,
it doesn't.
But if that's the case,
that doesn't mean it's not meaningful. That doesn't mean it's not meaningful. So there are many
what it means
important.
That it becomes a speculation that we have no methodology to show isn't purely imaginary. Right? Like all of us can sit and come up with 1,000 possibilities of what could be the case.
We need to pare them down, and that's where science can help. But the fact that a scientific theory is mute on which possibility is going to happen is consistent. It's logically consistent with the existence of an intentionality on the part of nature, because like if one wants the necessary who's the guy who came up with necessary that nothing happens without a necessary cause, that without a necessary cause,
you're talking about like the Kalam, the prime mover argument.
Oh, I guess so. There's a particular, I'm blanking on it, principle of sufficient reason. Principle of sufficient reason that you've got. Yes, Leibniz's principle of sufficient reason that you've got a donkey, equally and a donkey, and there are two equally. This is a political cartoon that someone did based on that. Starving donkey, two identical bundles of hay. No reason to choose one or the other. That donkey's going to start eating one because whether or not he's got it, he's going to pick one. So this is the kind of thing I'm talking about. If nature has this. And I'm not asserting it does, because that would be fanciful speculation. I don't know that. But I'm saying if it did, then this is the kind of theory that you would have to have, because that it can't say, because that's the only way that intentionality actually has a scientific basis. Ironically,
I think that's
human
being-
intentionality has no scientific basis at all, unless your theory leaves room for it, at the very least. And in the Newtonian deterministic paradigm of everything, robotically, dominoes, that's what it is. There's no intention there.
I share David's intuition in the context of and I would actually change it slightly. I would say that this idea of an indeterminate ontology doesn't make sense to me. I think the problem is with our epistemology, not with the ontology. I think the assumption or the view, I should say, that nature itself could be indeterminate.
But only with respect to specific outcomes, which are actualized events. It's not indeterminate with respect to. I mean, in the theory that I offer, in the formulation that I offer, there is a clear and well-defined ontology. It's simply that the ontology is a richer one, in the sense that, again, below the submerged iceberg, the tip of the iceberg is what's going to get actualized in my measurement. The submerged portion is what is really going on underneath and what are the possibilities. That's very well defined. And it's defined in a quantitative way, very specific way, and I lay it out of my book. So there's nothing vague about the ontology. It's simply that what's going to get actualized at the tip, or the phenomenal level, is not determined by the theory.
Another quick question to pop in here for you guys. Does scale matter here for what we're talking about? Everyday events, like, am I determined to go to the store depending on quantum level, or can that be different?
If you have any real choice about whether to go to the store, then the only place that real, genuine choice, live choice, can come from is the quantum level, because it's not going to come from any deterministic causal theory. So if you do have it, that's the only place it's going to come from.
I would say that a context of indeterminacy or randomness doesn't itself lead
randomness is a tendentious term, because it smuggles in this idea of it precludes the idea that there's intentionality or volition. I don't use the word randomness because I feel that it's tendentious. But
I would rephrase it this way. I don't think, and I remain of the opinion that I have not heard of a notion of volition that is actually expressing something that's coherent to me, and I don't think that a view. I think I even have an issue. Again, this is just my intuition, so it doesn't really mean anything ultimately for what is true. But I'm just expressing what my perspective is. That this idea that there is a reality out there that is not actualized, that there is some potential before some actualization. To me, doesn't make any sense either. I think.
Look at the quantitative, presentation in my book, where I do. I think it can make sense if you read it. I mean, obviously, based on what I'm saying here, there's not much to go on, but it is laid out very, very in very specific terms, very quantitatively. But I would ask Cease, I would say, do you the term intentionality? Do you feel that that's a meaningful term?
I think that it's any decision we make, to me, only makes sense in a deterministic context. That it's just part of a chain of events that we do not freely author in any kind of way. Now, I would be happy to be wrong about that.
So you see a that doesn't answer my question about intentionality. So
he was like mid thought though.
I'm saying any notion of intentionality outside of that framework, I don't know what is meant by that. The same way that I think
you would define intentionality as, like being sort of a link in a chain of causes, carrying out the deterministically mandated effect of prior
Yeah,
causes.
that
And that
will
would
is
be
just
your
engaging.
intention.
Yes, that our
So
will
you-
is
so-
just a recognition.
So it's
of
superfluous. So it's just sort of a, it's just sort of a it's sort of like a domino falling and having some subjective feeling about his fall.
yeah, more or
Is that
less.
what intentionality would be?
That we can wish for an outcome or want an outcome or engage in uh, um, ending up in an outcome, but nothing of that a process is free in the kind of sense that I think you've been talking about.
Okay, so then intentionality on the part of, say, a domino would be like, I intend to not fall. I intend to not fall. Oh, oops, I fell. So like whatever, I mean, because intentionality involves projection of a desired, or willed outcome. And so in a deterministic theory, such a projection would be idle in a sense, because it's
the desire
irrelevant.
itself. Well, or the desire itself would itself be part of a causal link. The reason why I have X desire is because the prior brain state led me to have that desire. It's not that I.
Isn't that-
Okay, but I guess I
Is
would
that a
distinguish between
tautology,
desire
though?
and intention. I would distinguish between desire and intention, because intention is the thought that I plan to make such and such happen. I intend to make such and such happen. And so
Yeah, I would say that all of
that
that
kind
is
of thought on the part of a domino is clearly is clearly kind of an idle.
Sure.
irrelevant
Yeah, I would
thought,
say
'cause
that all of
what's
that
going
is
to happen
maybe-
has nothing doesn't care about what the domino intends to do.
Right.
Maybe I should comment at this point that we've been dealing with what seems like a fundamental problem for now basically a century, right? Quantum theory is almost 100 years old, and this looks like a fundamental problem, but there is a growing group of people who basically sidestep the issue completely and see no problem whatsoever, and these are the many worlders. Right. So, of course.
Oh, yeah, but they have a problem. They just don't want to notice that they have a problem. Yeah, I have some references on that too. It many worlds fails on for instance, the inconsistencies like the Wigner's friend and Froschiger-Renner inconsistencies, and I have a reference for that too. And basically, I know that that's an attempt to sidestep the issue of measurement, but it really doesn't work. I'm making a dogmatic statement here. I will provide, references demonstrating, I think, presenting an argument why it doesn't work. And those arguments are generally ignored, in the literature because of the historical weight of Everett's, had a neat idea and it really hasn't worked out. But the fact that it really hasn't worked out is generally not recognized.
Can you describe in a simple way what that problem is?
Well, there's
because I just wanted to point out that
it's circular.
Well,
that the basis for splitting is always the one that you want to end up with classical phenomena, as opposed to some other basis with you could equally split in a cat in a superposition of alive plus dead versus alive minus dead. So they help themselves circularly.
Okay, so I think they call this the preferred basis problem, right?
Right,
they refer to this as the preferred basis problem. So they are addressing this, and some people have claimed that they have a straightforward resolution to this.
Yeah, and I've read those, and they do it by kind of helping themselves to the preferred basis, and saying that nature does this, and they always have ultimately an ad hoc reason for that. But the more serious problem, actually, and I have a reference for anyone then and others is that it is subject to the same Wigner's friend inconsistencies, and it is subject to an empirical clash where two different observers, according to this unitary evolution that denies that there's ever any actual measurement interaction, but that just sort of it claims that all you need are correlations to get measurements, and following that course lands you in inconsistencies, and they also are basically ignoring that finding. But yes, I will put that up right now. Let me see. So
Yeah. So if you
and
if you
I
got links to any of your references, just drop them in the side chat here.
right.
I'll put them in the live chat so our audience can see them. And I did have a question. The people are kind of wanting to know more details about the inconsistencies and what sort of
Gotcha.
inconsistencies are we looking
So
at? Uh-huh.
the inconsistencies for the standard theory, including the Everett interpretation, is, I'm just going to drop this in here where I've written it. This is a contribution to a special issue of a journal that's honoring Roger Penrose. Now, I don't happen to subscribe to Dr. Penrose's particular collapse approach. I have a different formulation that gives us collapse, but I think he's right that you don't get any real, reason to have any measurement outcomes in a consistent way unless you have this real what's called non-unitarity. But it's basically the old, Wigner's friend thing, where it's a variation on the Schrodinger's cat experiment, which was a reductio ad absurdum of the standard theory by Schrodinger. And it has not been recognized as that, but it was basically an argument that, look, quantum theory has a problem because it doesn't tell you what measurement is. And you imagine he must have hated cats, right? So you put a cat in a box with a radioactive atom, then and a Geiger counter that's hooked up to a poison gas, so that if this radioactive atom decays within the 1 hour, then the cat will be killed by the poison gas, and if not, then it won't. And the standard theory describes this whole setup by this massive giant superposition. And then supposedly you only find out when you look in the box, where they can't say what it means physically to look in the box. So Wigner said, okay, I'm going to replace the cat by a friend. Wigner's going to put his friend in the box. And well, why can't his friend see an outcome? What is it that gives you an outcome? And this is the standard theory measurement problem aspect 1. And so it's these kinds of inconsistencies where they have now said, okay, the friend in the box is going to see an outcome, so he's going to describe his quantum state with the appropriate eigenstate. That's the term for outcome state. But meanwhile, Wigner outside has to describe the entire situation by this giant superposition, like the Schrodinger's cat. And they doing it, they have inconsistent state descriptions that result in problematic, fatal, empirically fatal inconsistencies. So this is why, the standard theory utterly fails to even be self-consistent. And this point is so far being kind of, the eyes are averted, because this basically kind of kills all of the, if it's a correct objection, and I invite people to read the paper, decide for yourself if the objection is correct. If the objection is sound that I've laid out here, and and view these inconsistencies, then all the standard interpretations, the Bohmian theory of many worlds theory, all the interpretations for which there is no real measurement interaction, are subject to this fatal inconsistency. So that's just, the measurement problem part 1 is really fatal for the standard theory, even before we get to this, perplexity of, oh my God, why are we getting one outcome out of many?
I want to hear from Ben as well, if there was something you wanted to add as well.
I'm sorry, somebody calling me for something?
No, I'm just curious to hear if there was anything that you
Well, there's some contention between positions here. We kind of want to know where you stand, Ben.
Well, I think the problem here is that we have a lot of things that we still don't know. I mean, and that's part of as Carl Sagan said, that's part of the beauty of science, right? Is you're always pushing the shore back. You're on an island, you're always pushing the shore back, and you're moving that ocean of ignorance further and further back. But when you start talking about free will, you're starting to talk about psychology. And I've said for a long time that I don't try to understand people. They're too complicated. I can understand objects, but I can't understand people. So when you start talking about what decision I make and whether I'm going to go to the grocery store or not, that could be affected by what I've eaten for lunch that day. And so the field of psychology doesn't know enough about that. And the field of medicine doesn't know enough about that for me to make any predictions about what the individual atoms are going to do but we know they're all going to collectively move. So scale does matter. And, once you've decided to throw the baseball in that direction, it's going in that direction. If you try to do that with an individual atom, though, you can't make that kind of prediction. It's going to maybe go that way a little bit. It's going to go maybe that way a little bit. And it's not just because it might bounce off of other particles. Even if you do that in a vacuum, there's going to be some uncertainty there. So scale definitely matters. And we can't make predictions on the type of macroscopic systems that we're talking about here. So this, to me, starts to feel like, and I don't mean to be insulting here, right? But this, to me, starts to feel like the same kind of arguments that people used to have 1,000 years ago about how many angels you can fit on the head of a pin, right? We don't know anything about what angels are capable of doing, so we can't really have an intelligent discussion about that. And I'm afraid that's sort of what we drifted off into with some of what we've been talking about here.
Yeah, and I get that. I totally get that concern of Ben's, and I think the only reason that came up is because Heisenberg himself would use language like it's as if the photon is making a choice whether to go through the polarizer or not, and that's why it comes up. But again, I would never, I don't claim that we have free will. I don't purport to know that. All I do is I tend to push back when people use science to rule it out, because I think that's a mistake. And this is where I think as scientists, we need to be humble. We need science. We need to recognize what science is mute on. And it's totally mute on what are human beings going to do.
There should be humility in science, and I agree with that. There's a whole lot of things that we still don't know. And so,
Absolutely.
Yeah, we should be humble in that regard.
So we have another question that I did want to get to, and then we probably need to start wrapping things up because I know Cease has got to go here shortly. So let's see. I have another question about time too. I assume they know of A and B theory of time, philosophy of time. Does that affect this, and how does that play? And if so, basically. A theory of time and B theory of time is a theory of time is that that time exists independent of space, and then B theory of time is basically space time are tethered together and expanding, is my understanding. So, panel, you want to tackle this?
I don't want to say too much. I talk about this in my book, but I'll just
we'll go through like we did at the beginning here. Yeah.
Okay.
We'll let David and then Cease and Ruth and Ben.
Okay, without going into the details, I'm not a philosopher. These theories of time have existed for quite a while, and I think my short answer is that they are basically incompatible with relativity. But I wanted to comment on the idea, the fact that, in my experience, people who explore quantum theory tend to form these camps, and they seem kind of dogmatic. They're all very sure about their positions. And Dr. Kastner, you mentioned, for example, fatal inconsistencies in other approaches of quantum theory. And if I talk to other people, I've heard many worlders say that it's not worth their time to go to conferences and talk to other people who have other views on quantum theory, because the experimental evidence is clearly in favor of the many worlds. I can't imagine anything more dogmatic than that. So
it's not even true. Yes.
They say that the opposite is true.
It's like,
from an outsider's perspective, how do we make progress if people think that the other interpretation of quantum theory is ridiculous? So I'll just throw that out there. That's my experience.
All right, let's Cease get some input on this, and then.
As far as the question about time, I'll just say a quick thing. I think the more time goes by, the older I get, the more I realize how little I know of anything. I don't think any of these ideas are clear. I think it's all ambiguous, and I'm just trying to do the best I can here to navigate what these ideas are even suggesting. I think my closing statement for the conversation, I think, will be the following. I agree that anybody in any field should remain humble. I think we can all agree on that. I think where my concern lies is, again, in how we translate the science into something that we can all comprehend, and also where, look, where science is silent on an issue, I don't think that there is some other tool or methodology which can tell us how things are. And I'm not even convinced that science succeeds in doing that a lot of the time. That's not a knock on science. I think science is the best tool we have compared to anything else. I don't think there's anything that is as successful or as useful as science. And yet I'm concerned with what I think are some issues in principle. Whether, like what we're talking about, whether it's measurement or perceptions or how we're expressing these ideas. I think in a context where now we have abandoned falsifiability as at least a factor in how we're navigating what we're talking about, I don't know that what we're doing is any better than just speculation. I mean, just because something is logically consistent doesn't mean that it's corresponding to anything meaningful about the way things actually are. And so, it was mentioned, science has to leave room for a notion of free will. What I would say is that I still haven't heard the notion of free will that I even understand. And so it's not that I'm in principle against it or that I think science should be in principle against it. It's that I don't even know what people mean when they use the word. I think it's a confusion of language, ultimately. And if you want to speculate that nature itself, there's some fundamental volition to nature itself, if science can speak on the matter, then I don't know what we're doing. Then I don't know, how do we ground this notion as something that is reasonable to believe corresponds to reality as opposed to any other idea that we could come up with, any kind of possibility. I find this to be concerns of mine. Again, I'm not arguing for any particular perspective. I mean, I have no idea what is the case. I just think that it's all fairly ambiguous to me. I'm open to whatever is true, if we can find a way to understand that truth. But I'm just concerned about the success of these tools, I guess. That's it.
Okay, well, I guess I would just, as far as the A and B theories, I do discuss this in my book in chapter 8, and the A theory is more of like a dynamical sense of temporality where there's change and real change and becoming, and the B theory is more about like a static picture that's like a block world picture, and I think that physics can definitely support either one depending on your interpretation, but I think it's more you ignore less of the physics if you approach it with the A kind of series, that there's physics that corresponds to this becoming. And as far as Ceasetoknow, I think he's concerned, maybe there's a misunderstanding maybe about some things I've said, because he seems concerned about things that I don't think I'm doing. I mean, I would never say that science should leave room for free will. No, it shouldn't. And I don't think I said that. I'm just saying that if, that the only reason it came up is because of this concern about the apparent indeterminism of quantum theory. And so that, and again, we know that, when Heisenberg first came up against this, he talked about, the photon choosing, and he used language, he used intentional choice language. So that's a way in which the theory just sort of naturally leaves an opening for that kind of concept that I don't pretend to know or have a definitive view of that. I'm just saying that would be I think a sound inference from a theory that that if it's fundamentally indeterministic, it's mute on what's going to happen. That's the only kind of physical theory that can even address or leave room for these kinds of if you will, psychological things. But again, who knows whether psychology is only an attribute of humans, or what we take as psychology. But I mean, I'm no friend of psychologism, and I'm definitely against flights of speculative fancy, and I'm in favor of listening to a theory that is successful in terms of falsifiability. I certainly have not thrown that out. I mean, I just kind of objected to it being invoked as a particular objection to one thing I was proposing. But of course, many times theories have been falsified. For instance, the standard quantum theory is falsified by experiment, and people are not paying attention to that because they're so entrenched in it. So yes, falsification is definitely important. When you've got anomalies for your theory, you've got to take this seriously. And it's just a question of, like if for instance, if the square in Flatland, go back to our Flatland picture, is visited by the sphere, and the sphere pokes him in the stomach and leaves, and the square goes, oh my God. And someone says, and the square says, I just got, poked, I just had this sensation, and I have this theory that there are possibly higher dimensions, and that my theory would predict this or that, and my prediction was borne out where I got poked in the stomach and it really hurt. The squares around him would say your theory is not falsifiable because they cannot see that in a third party empirically corroborated way. So this is why we have to be careful about what we decide, what we want to say is meaningful or falsifiable and so on, because it can serve as an inadvertent bar to inquiry. So I'll just stop.
So, like experiential. I mean, is that what you're saying? Is like
right? I mean, he definitely, there was if you were a sphere. If the spheres could go, ha ha, look at guys, our theory's been corroborated and we can see you poking him, ha ha ha. But his fellow Flatlanders are going to say that his theory is not falsifiable because it didn't provide any data that they can third party corroborate. So that's why it's very important, to kind of understand what is the scope of the demand for falsification, and that there's some nuance here. And that's something, just because it seems not corroboratable in the usual way does not mean it isn't correct or true or even scientific, right? But of course, I don't know that there's a higher space land out there, and I would never claim that there is. But the point is, it's a thought experiment that at the meta level of scientific, analysis, we can see that in this hypothetical situation, a lower dimensional domain, what counts as empirically corroboratable and falsifiable on what domain you're in and the scale that you're looking at things.
Let's get Ben in here before we close things out. Ben, final thoughts?
Okay. Space and time. We're talking about space and time. And are they interrelated, right? They definitely are. I mean, if you go down inside a gravitational well, if you go down inside curved space, then you watch the universe evolve in a different way than it does as if you don't go down into curved space. That's empirical. That can be shown. And there's math behind it. And so one of the things that is kind of it's becoming a pet peeve for me the older I get, is I kind of want to do this talk called The Case for Math, because everybody hates math and nobody wants to talk about the math, and the only reason I haven't done the talk is because I wouldn't have an audience if I made it. Nobody would want to listen to it. Right?
I'll watch.
Good. Well, that's one, right? But the argument
You got the quantum physicist.
Yeah. The argument that I make to my students all the time is that math is formalized logic. So you can't really explain what's going on in the system if you can't make a mathematical model to describe it. And, maybe that's unfair. Maybe that's being overly anal on my part, but that's what works for me, right? And so, like my personal thing is that I kind of view time, because nobody really knows what time is, right? And that's the real question. And so I kind of view time as the expansion of space, and that's what allows everything to sort of move around, is that expansion of space. But I would never publish a theory. I don't even like saying it out loud, right? Because it works in my head. But I would never publish an article or write this theory up and try to publish it without having some sort of math to back it up or some way to empirically test it. And if I don't have that, then it's me just playing games in my own head, right? Maybe I'm onto something, maybe I'm not. And so these philosophical discussions, it's sometimes I feel like it's too easy to start playing around in your own head and not really know anything. And so that's where I struggle. That's why I just kind of sit here and listen when we go into those kinds of discussions, because sometimes I don't know what to say about it.
Me too, Ben. Oh,
Well,
all right.
my paper on the Born rule does have some math in it, and it sticks to the math to try to explicate the issues. So you may find that worth reading.
Yeah, somehow we need to start building some of that out, and I'll go back and read the paper. There's no doubt about that.
Cool.
But somehow we have to start building some of this into some of our discussions, and get away from maybe the language and the hand waving, and actually have some way to discuss this in a more mathematical framework and a more structured framework without boring everybody to death when we do it. And that's the problem I can't solve. That's the one I've been working on.
I try to do that in my books. Yeah, I try to do that in my books.
We got a special kind of audience around here. They're all a bunch of nerds, and they love math. They're cheering for the idea of you doing that presentation, Ben.
David, do you have
All right.
I will tell you that I did try to do a presentation at LibertyCon in July about Hamiltonian Lagrangian mechanics, and I have a certain group that's always sort of devoted to me, and they showed up. There were 16 people in the room. It's the same 16 people I see at every talk I give, and even they were giving me looks like I had two heads by the time that 50 minutes was over, or falling asleep. Pick one or the other, but everybody in the room.
I'm just putting up my chapter 8 on space-time on the chat here, where I have some very quantitative discussion of space-time that hopefully Ben will enjoy. So,
all right. I do want to thank our Wes. Can I get our patrons up here so we can go through that? Just want to give them a quick shout out. The people who make this possible for us to get together and have these fun discussions. We have. I don't know them by heart, sweetie. You got to put them up on the screen. And we also have several other programs on this channel where we discuss other interesting topics, from social topics to science topics. And I want to thank Sidney Davis Jr., Eric Ozols, Ryan, Deneen Murphy, Dan D, Michael Wiseman, Kathy Cotton, Cindy Plaza, Sunny Shell, Aaron Coalson, Phil Calderone, I always mess up his last name, Calderone, and Amanda McLeod. Thank you so much for all you do out there. Loving our videos, hitting that thumbs up button. To everybody out there watching on the live chat, thank you so much as well. We appreciate all the discourse and the questions from the audience. We've got our other shows that you can pull up here for me, dear. So we can, there we go. And don't forget to check out our other shows on Skeptic Haven, the Secular Soapbox on Wednesday. Thursday is the Sunny Spot, where we're at right now. And Saturday, we got the Global Atheist and Women Atheist Unloaded. And then on Sunday, we got our call-in show, which is called Let's Talk. So if any of that interests you, come check it out. We have, we're always going to have great guests like these people to come together and have discussions. And sometimes it gets heated, sometimes we laugh, sometimes it's just a good time, and everybody's deep in thought. So I really appreciate everybody's input tonight. Did anybody have any last words to say before we close the show out? All right.
Just thanks
again.
Thank
you for having me on. I appreciate it.
Thanks.
Yeah.
Thank you.
Thanks
really
for having
It's
me.
been amazing. Yes. All right. Well, I guess take us out, Producer Wes. Thank you so much. And please remember to be kind and take care, and we'll see you next time.